Hey, we have another integral here today from the MIT Integration Bee 2023. This was regular season problem number 3. We have the integral from 0 to 3, the min of 2x and 5 minus x over 2, minus the max of minus x over 2, 2x minus 5 dx. Okay, interesting problem here with the min and the max function. When I started to look into this problem, you realize that it's really not going to be too hard because the thing is we have each of these functions in the min and max, these are all linear, right? There's no squared terms. Everything's just an x. And then when we look at the slope, like here we have a 2, here we have a minus half on this one, 2 minus half. So since the slope is different on these two and different on these two, just being very general with the graph, we're going to have some kind of intersection because we know these are linear and they're not parallel with different slope. Now we don't know that they're intersecting within these bounds. Our bounds are like if this is 0 and we have 3 here. So we don't necessarily know that our intersection is going to come between 0 and 3. If the intersection happened outside of these bounds, it would be less interesting because then it would just be like a single function. But anyway, with a graph like this, it's going to be easy to identify like the max is going to be our upper curve. Like in this region, the max is going to be here, and the minimum is going to be the lower part. So it's going to be very easy to transform this into an integral that we can do. But in order to do this, we're going to need to find this intersection point, but that's going to be very easy because we just can set these two equal. So I can say, I can create equation 2x equal to 5 minus x over 2 and just solve for x really quick. And so if I do that and solve, we're going to find here for this left one, x equals 1. So that's going to be one of our, we're going to have an intersection point at x equals 1. Then doing the same thing over here, we're going to have minus x over 2 equal to 2x minus 5. I'll just reverse the sign. Then multiplying through by this 2, we're going to have x equals 10 minus 4x, or 5x equals 10, or we're going to have another intersection point at x equals 2. So now that we see that we have intersection points at 1 and 2, those are both between our bounds, what we can do is just split up this integral based on these intersection points, and we'll have like different min and maxes in different regions. So let's see how this is going to look. So for my first one, I'm going to go from 0 to this intersection point 1. And then for our next one, we'll just go from 1 to 2. I'll give myself enough space. And then for the last one, we're going to go from 2 to the upper bound, which is 3. And then in each of these cases, we're just going to need to find our min and max real quick, but that shouldn't be too hard. Like starting from 0 to 1, what I can do to determine my min and max value in different ranges is just like plug in a value. Like for here between 0 and 1, let's just plug in 0 and see what we get. So if I plug a 0 in here, we're going to have 0. If I plug a 0 in here for x, we're going to end up with 5 halves. And 0 is less than 5 halves, so this is going to be our min in this region. So we're going to have a 2x here. Then I'm going to do the same thing over here for the max. If I plug a 0 in, we get 0. If I plug a 0 in here, I get minus 5. And 0 is greater than minus 5, so our max function is going to be this minus x over 2 here. But we have minus times minus, so I'm just going to change those to pluses. And then between 1 and 2, we know our min has to be this other function because we determined they intersect at 1. So it's got to change from 2x to this other function, which is 5 minus x over 2. Then here for the max, the intersection doesn't happen until 2. So we can just use this same function again, which is minus x over 2. And again, we'll change this to a plus. And then for this last one between 2 and 3, the min has to be this same function because again, the intersection was at 1. So we're going to have this 5 minus x over 2. And then for the max, it's going to have to be this 2x minus 5 function. And that's because we have the intersection at 2, so it's going to change it to. And of course, you could check it again. Like you could plug a 3 in here. If you plug a 3 in for x, you get 6 minus 5 is 1. And you plug a 3 in here, you get a negative number. So clearly, this is going to win. So again, we're going to use 2x minus 5 here. And then you can see we're going to have a really easy integral, but let's just simplify this. So here, 2x plus x over 2 is going to be 5 halves x. And then for this one, from 1 to 2, if you break up the minus x over 2 and plus x over 2, this is going to cancel with this, and you're just going to end up with 5 halves dx. And then for this one, let me just break this out separately so I don't make any mistakes. So this is going to be the same thing as 5 over 2 minus x over 2. Distributing in the minus sign, we're going to have minus 2x plus 5. And then combining like terms here, we're going to have 15 over 2 minus 5 halves x dx. And then we can just integrate this thing. So for the first one, this is going to be just power rule. We'll have 5/4 x squared evaluated from 0 to 1. And then this one, of course, is going to be 5 halves x evaluated from 1 to 2. And then this one's going to be 15 halves x minus 5/4 x squared evaluated from 2 to 3. Okay, and so now I'm just going to evaluate in order to finish this off. So I'll plug a 1 in here, and we're just going to get 5/4. And 0, when we plug 0 in here, of course we have 0, so I'm not going to worry about that one too much. Plugging that 2 in, we're just going to have a 5 here, and then plugging a 1 in, we're going to have a minus 5/2. Then for this last one, when we plug a 3 in, we're going to have 45/2. 3 squared is 9 minus 45/4. Then plugging a 2 in, we're going to have a minus 15. Then plugging a 2 in again, we're going to have a plus 5. Then we'll just simplify this really quick, cancel a 5 and a 5 and a minus 15 and get a minus 5. I'll get a common denominator here for all this stuff. And then when I add and subtract all this stuff, I get 20/4, or our final solution, which is just 5. Anyway, nothing really hard there. It's just kind of straightforward working through the steps. I think the only challenge in this one would be doing it in the 2 or 3 minutes that they give you, just because there is kind of a bunch of steps, but nothing hard, but maybe kind of time consuming. So we'll stop it there. Thanks everyone for watching today. Have a great day.